So we're going to talk about different environmental conditions such as low and high temperature, humidity, what it might require as far as mitigation strategies, where you're going to want to install those batteries. Are they going to need to be heated? Are they going to need to be cooled, ventilated, etc.? So we're going to talk about all sorts of installation equipment and strategies needed to mitigate any bad weather. So first, we're going to be talking about temperature considerations. We have our operating temperature range from 4 degrees Fahrenheit to 140 degrees Fahrenheit. This is operating in terms of either discharging or simply in standby mode, being stationary, turned off, not powering any load. As far as charging temperatures, SimpliPhi batteries can be charged between 32 degrees Fahrenheit, freezing temperature, and 120 degrees Fahrenheit. So this is a really wide window here. The low end is going to be where you're going to maybe run into issues, whereas the high end, it's very rare to run into issues charging or discharging on the high end of the temperature range. And part of the reason for this is because of our use of lithium iron phosphate chemistry. So lithium iron phosphate is a much inherently safer and just more thermally stable chemistry as compared to a lot of cobalt-based batteries. Cobalt-based batteries just cannot safely reach this type of temperature when charging, or you kind of risk getting close to a thermal runaway event. As far as storage, you want to be sure not to store these below freezing for too long. I mean, you can definitely keep them at -4 degrees Fahrenheit, like we mentioned, but I wouldn't exceed 3 months doing that. 6 months, anywhere from 14 to 77 Fahrenheit. Another thing to keep in mind with lead acid batteries in warmer, humid environments, they're going to discharge, self-discharge, and lose energy very quickly. You're going to want to keep those on a float charge. But with SimpliPhi batteries, they really hold their charge well, even in hot and humid environments. So it's really a great option as far as being able to just turn these off and decommission a system for a whole season, or even 3/4 of the year if you're only visiting your property for a short period each year, and maybe it's in Alaska, and then you leave everything turned off and decommissioned for the winter. This is actually a common use of our products. One thing to keep in mind, and we're going to talk about several of our products today, is with the Phi battery, as far as low temperatures, you're gonna maybe run into some issues here. The Phi battery does not have internal temperature control through the battery management system. So the temperature control here is up to both the customer and the installer. So you're gonna wanna make sure that you're not putting this battery in an environment where it's gonna get below freezing, because if you do attempt to charge it below freezing, it will accept the charge and it could damage the battery. Now, really, this is often not needed. So this is a simple battery technology, very tried and true battery that, if you're installing it indoors, which most installations are, and that space is within a reasonable temperature range, maybe it's heated, or maybe you live in somewhere like myself, you're lucky enough to live in California or Florida, somewhere nice and warm and consistent, then you really don't even need to worry about temperature management and charging below freezing. We're going to talk about some mitigation strategies if that is something that you're going to run up against. So our SimpliPhi battery does offer much more advanced temperature control and protection. So this is a better option for those of you who are going to be installing batteries outside in a cabinet or in a non-insulated shed in an environment that could get cold. Now keep in mind, our Phi and SimpliPhi batteries are not outdoor rated. We are now offering a new ESS system that is outdoor rated and has much more functionality, especially as far as temperature goes. And if you are installing a system outdoors, tune back in for our upcoming ESS training on our training calendar. However, today we're just going to talk about our standard product line. And note that these two batteries are not outdoor rated. So really, you're going to need to protect them from rain and wind and sun somehow. They're not going to be standing up to the elements on their own. So it's easiest to just insulate that environment or heat that environment. But with that said, the temperature range of the SimpliPhi battery is the same as the Phi, but it now has those added protections from the BMS. The BMS is going to provide 2 layers of protection. So one layer of protection is the actual communications ports on top here. The battery itself will communicate with a compatible inverter charger. And in turn, the inverter charger will listen to the battery's commands. So the battery will tell it, hey, I'm getting cold. I'm going to need you to slow down this charge rate, or maybe even shut off charging entirely, depending on temperature. The inverter charger will listen to that and ramp down the charging rate as it gets colder and colder, and even turning it off as it gets to the point where the battery cannot accept a charge anymore. In addition to the communications causing that protection there in terms of cold weather, there's also communication within the battery itself. The BMS kind of has a fail-safe there in case the communications fail. But really, if you're using this battery in a cold environment, you definitely want to make sure communications are active. When you're considering, cold temperatures and where you're physically located in the country, your environmental conditions, you also want to think about the actual installation site. So some people see our temperature range of 32 to 120 for charging temperature, and they think, oh man, well, last winter it dropped to 20 degrees once here, and I can't install my batteries there. That's going to void my warranty, and that is not the case. The case is you want to think about the internal temperature of the actual battery. So if it's 20 degrees Fahrenheit outside and your batteries are encased in a shed that's partially insulated, and then beyond that, maybe they're in a cabinet, etc., all those layers of insulation are going to keep the battery warm. And in addition to that, the battery itself has a large thermal mass. So as it gets cold outside, the battery is going to maintain its heat for quite some time. So for example, overnight the temperature is dropping. The battery is still a few degrees warmer than any ambient temperature surrounding it at pretty much any time, unless it's immersed in those cold conditions for a very long time, maybe a day or so, and allowed to acclimate. So do consider the place that you're actually installing the battery. Are you going to have it insulated? Is it going to be warmer than the ambient temperature? If you're just installing these outside your home, on the wall of your house in an access or boss cabinet, the access or boss cabinet with no insulation is a big metal box, and that is going to very quickly acclimate to the outdoor temperature and definitely be about the same temperature as the ambient environment. Note that when you have your batteries installed in the cold environment and you did not consider that in the design at all, that can lead to a loss of capacity at temperatures below freezing. Now, this isn't huge, talking 25%, maybe 10%, depending on the weather. It can reduce the cycle life if you're charging quickly at very low temperatures, and it can reduce the cycle life even further if you're charging well below 0. So one thing you can do to prolong the life of your battery, maybe it's in a telecoms application, for example, where you have no choice but to continuously charge at a low rate, even in cold weather. You can actually reduce the charge rate to the following, and it will greatly reduce any damage that could be done to the battery and prolong its lifespan. So, for example, the SimpliPhi BMS automatically will curb charging rates to what you see here on the right. So for any installation or any battery temperature below 20 degrees Celsius, it's going to completely cut off charging capability. Any installations negative 20 to 10 degrees Celsius is 1 amp of charging, negative 10 to 0 degrees Celsius, it allows 3 amps of charging, and so on and so forth. So the SimpliPhi battery, the BMS is going to report these values automatically to your inverter charger and ask that it reduce charging to those rates. And the Phi battery, again, is not going to have this capability, but if you were in an application where you really had no choice, you could reduce charge rates to the following, and it would definitely assist in prolonging the lifespan of the battery as long as possible. So some other considerations to be made are, mitigating the temperatures. So if you've got cold temperatures outside of the battery cabin, maybe you have the batteries in a cabinet or a shed, just mitigating the cold temperatures, so keeping that area warm. There's several ways that you can do this. So if you're in an environment that's going to consistently be warm, we're talking a long winter season, not just a couple days within a year, that maybe an hour or two of those days drops below freezing, but we're talking a really cold environment. Here's what we'd recommend is, if you're putting it inside of one of our metal cabinets, I would use a rigid foam insulation. So this foam insulation's got to be able to really support the weight of the batteries, because if you've got insulation and then you compress it, all that air trapped within the insulation is now gone, and the insulating value is greatly lessened. So a rigid foam board is going to hold the weight of the batteries underneath of it. It's going to prevent the batteries from just pushing all their heat out through the metal cabinet of the boss enclosure or access enclosure. And the foam board is really going to help to keep the internal temperature of the cabinet up. One other thing to keep in mind here is, if you have additional electronics within the access cabinet, such as inverters or charge controllers, now these are going to generate some heat. Batteries on their own are very efficient and 99% efficient each way. So you're only losing 1% of the energy you put into the battery and 1% of the energy you take out to heat. But other power electronics are much less efficient. You're looking at losing anywhere from 5 to 10% often per device. So this can generate quite a bit of heat. And if you insulate the cabinet well, when trapping that heat, it can really help to keep the temperature up. So this is the easiest way I find to mitigate cold temperatures in moderate environments, is just insulating alone. Another thing for, I'd say, much more extreme climates where it's absolutely necessary is a heating pad. So heating pads can add cost and complication to the design, quite frankly, but if there's no other way to keep the batteries warm, these are a great option. Reason being is the batteries need to be ordered ahead of time. They've got to put thermistors into the batteries to sense the temperature, and then the heating pads are placed underneath the battery, connected to the battery thermistor, and then connected to the inverter for power. So they do run off the inverter. They don't run directly off the battery, so that they don't completely drain the battery. There are many ways you could go about this. So we can provide heating pads and, like I said, batteries with thermistors. There's also heating pad solutions where you can kind of customize your own relay and temperature controller. I think that sounds like a whole lot of work, and I really wouldn't recommend going down that road if you don't have to. But you don't have to purchase a heating solution from us. We're pretty open to whatever you have as long as it's safe and it works properly. I have seen some heating pads malfunction. I'm unsure if they were set up incorrectly by the installer or if there was a manufacturing defect in the heating pads. These were not heating pads that we offered, which is why I really like to stick with solutions that we manufacture and provide for you. One more consideration on the heating pads is these do use a considerable amount of electricity. So when you're using heating pads, be sure to also insulate the space. Now, if you're not insulating the space, imagine putting these on the bottom of a cabinet where it's freezing cold outside. That cabinet's going to be just sucking all the power out to the external environment from these heating pads. So you're going to be just running these all day. If you insulate the cabinet, you're going to use way less electricity to keep these batteries warm. Now, there is even another way you can mitigate cold temperatures by simply preventing charging from an external device entirely. So if you don't have SimpliPhi communications with a compatible inverter charger, another thing you can do if you're using Phi batteries is just use a Victron charge controller with a temperature sensor in tandem. The temperature sensor will attach directly to the battery terminals and tell the charge controller an accurate temperature for the outside of the battery case. The BMV is going to work the same way. The BMV is going to have a temperature sensor that goes right onto the battery terminal and provides temperature readings to the BMV. The BMV and charge controller can then in turn, if you've got the Victron products, in addition, other than these, it can report temperature to those and prevent charging in those devices as well, such as an inverter charger or maybe an alternator charger. You can communicate with all sorts of Victron devices from one another. Now, the only downside I would say here is the temperature sensors used in these devices are external to the battery. So this is not something that's inside the battery sensing accurate cell temperature right on the cell level. It's just outside the battery case, which can differ sometimes significantly. On the bright side, that's going to differ in a more protective way, right? So if it's cold outside, the batteries, like I said, are always a little warmer than the ambient temperature. This in turn is going to sense the colder temperature and be more on the protective end. Now, hot temperatures, I know we've just talked about cold temperatures for maybe 10 minutes, but hot temperatures are really not as much of a big deal. It's less often an issue. The reason, again, is that lithium iron phosphate batteries are just so thermally stable that they can handle a high temperature even when charging. And I'm talking up to 120 degrees Fahrenheit when you're charging, and even 140 degrees Fahrenheit when they're just sitting idle or discharging. So occasionally, areas like deserts and airtight enclosures with no ventilation at all will bump up against this type of temperature limit. So really, it's the similar systems to cold weather. You could use a temperature sensor. The Victron devices can be programmed as far as high temperature as well, and the SimpliPhi is going to have high temperature protection as well when paired with a communicating device. So there's definitely similar ways to mitigate these. It's just not as commonly an issue. Also, note that the battery's internal temperature is going to be usually less hot than the outside temperature unless you're charging. If you're charging the battery, it is generating a little bit of heat, might be warmer than the ambient, but in general, it's going to trail behind the ambient temperature slightly, just as it does in cold weather. So as the temperatures rise and fall, the batteries are slower to catch up, and they're always kind of remaining more moderate than whatever the ambient temperature is. So that's enough about temperature for now. Let's talk about humidity. Now, humidity itself does not pose a significant threat to the batteries, and it does not void your warranty. There's no problem installing our batteries in a humid environment, even somewhere like Florida, which can be very humid for all the time. Even consistent humidity is not a problem. The issues arise when you're very close to the ocean, and there's going to be not only humidity, but also maybe a salt spray. It's a metal case on these batteries, so even though it's powder coated, corrosion is a real concern. It's something to make sure you don't provide a good environment for corrosion. You want to ideally have a dry and non-salty environment for the batteries to live in. But again, humidity itself is not the issue. It's really more if you have an environment that's going to be getting hot and cold back and forth, and there's going to be a lot of condensation forming in that area. In addition, a salt spray. We are manufacturing our batteries in Oxnard, California. We're about 5-10 minutes from the beach, so it's really not a problem to be near the beach. It's just making sure you don't have that salt spray. Being right directly on the shore is the only place that would really cause an issue there. Altitude is another good question. We get a lot of inquiries saying, hey, can I install your batteries over 10,000 feet? Can I install your batteries on the middle of Pikes Peak? I mean, lots of interesting installation questions that we get. In general, there is no specific altitude limit. The batteries that we use are manufactured with cylindrical cells. Cylindrical cells have steel casing on the exterior that can really stand up to intense pressure differences between the inside and outside of the cell. This is a stark contrast to pouch cells. So now pouch cells, they don't have a rigid housing. Their housing is flexible. Therefore, I would not recommend pouch cells in a low pressure, high altitude environment. Really, for our batteries, the main concern in high elevations is temperature, because the air at high temperatures is less dense, and then it has reduced heating and cooling potential. So this, high temperatures, high elevations are often the same place you find very low temperatures, and in general, having that air have reduced heating and cooling potential combined with the low temperature, that is what can cause issue, is really temperature. So hate to be that guy, but as you asked the altitude question, I'm always pointing you back to temperature and saying, hey, that's the real thing to be concerned about. You can definitely install our batteries over 10,000 feet if it's a very climate controlled environment. One thing to consider though, beyond batteries, is that a lot of the other power electronics are going to have some type of limitation as far as altitude. And I have found it hard to find an inverter, charge controller, etc., that can be installed over 10,000 feet without, specifically reaching out to that manufacturer. So double check on that information first. Those power electronics are often much more restricted in terms of temperature range and altitude range than the batteries themselves are. You also want to keep in mind voltage at altitudes. I mean, if you're going with a really high voltage device, there can be an increased potential for arcing. The air at high elevations is actually less insulating than it is at low altitudes. So again, just keeping a low voltage system is important. 48 volts is absolutely fine at high elevations, but going to high voltage like a 600 volt residential battery is probably not a wise idea at high altitudes. Vibration. So looking at mobile applications like RVs, boats, vans, it's important to ask the question of, can the batteries stand up to the vibration they're going to be handed? Now, again, I'm going to point out that our batteries are produced with cylindrical cells. So these cells they have a very rigid casing that's strong, and it can stand up to a lot of abuse. Whereas something like a pouch cell, again, is just not designed for this. And unfortunately, I seem to be seeing more and more of these cheap pouch cells used in mobile marketed batteries. So I really would look into the construction of your battery if you're using it for a mobile application. Now, our batteries were designed partly for a Department of Defense project where they were going to be traveling through the mountainous terrain of Afghanistan. So in general, they really were designed to be tolerant of vibration. We even have developed products in the past under the name Liberty Pack, is kind of a branch company we used to operate under, and Liberty Pack made mobile equipment for Hollywood filmmakers. So this is something where, again, we're making small enclosures that would hold a battery and an inverter and be able to power film equipment. We really do understand mobile applications. We've been in that industry, and in general, life in an RV is going to be much more easier and gentler on the batteries as opposed to filmmaking equipment or the Department of Defense, which our batteries are both able to handle. So it's totally not an issue to use our batteries in high vibration environments. And there has been some specific testing done, which I'll talk about a little later today. So as far as the testing that has been done, we do our own, internal quality testing and lab testing as far as charge and discharge. I can't say that we necessarily perform very intense, rigorous vibration testing or altitude testing at our own facilities, but that's something that is done elsewhere, like the UN 38.3 test. This is required if you want your batteries to be able to board an airplane. So if you want to be able to airship your batteries, you've got to get this UN 38.3 test. One thing that we do or is done to our batteries during this test by a third party is an altitude test. So this is going to store the batteries at a very low pressure, which simulates high altitude. It's going to cycle the batteries between 72 degrees Celsius and 40 degrees Celsius and do that in rapid succession. Going to give the batteries 36 hours of intense vibration simulating transit, so being in the back of a cargo van, and shock by repeatedly dropping the batteries to simulate a crash within a vehicle. To pass these tests, there can be no leakage, venting, disassembly, rupture, or fire, and they're going to check the open circuit voltage before and after the test, and it really can't change all that much. Even more tests, there's an external short circuit, which is heating a battery to 57 Celsius for 6 hours and then short circuiting the terminals externally. Battery cannot exceed 170 Celsius or catch fire. And overcharging to 1.2 times the max voltage, the battery cannot catch fire. Note that all these tests I just explained to you were performed on our batteries by a third party. So you can review all the tests that are done to batteries for UN 38.3 testing. It's public info. You can review it here. But it's important to keep in mind that although these tests were performed to our batteries and no catastrophes have happened, these aren't necessarily in spec. We don't want you to do these, and doing them could probably void your warranty. There's been a whole bunch more safety testing done to our batteries as well, all the way from the cell level to an entire system level with batteries and inverter as a whole. So 1642 is a cell level test that's very similar to what you just heard about. We're talking about shock testing, drop, vibration, heating, temperature cycling, low pressure, short circuiting, and much more. Even crush testing, so just smashing that cell and making sure there's no fire. UL 1973 evaluates the battery as a whole and its ability to kind of withstand abuse, I would say, and be just generally harsh treatment of the battery, make sure there's no fire, make sure it still works. And UL 9540, this is a system level safety test. It's going to verify not only that the battery is safe, but that the entire system, meaning battery and inverter charger, are going to work together safely. For access and BOSS configurations, we have finished all necessary testing, so we do have UL 9540 completed and ready to go. This is something a lot of jurisdictions are asking detailed questions about, wanting to see our 9540 certification. And a lot of them are wanting to see our 9540A report, which is something that we have. 9540A is a test method. It's not necessarily a certification such as a pass or fail. 9540A is basically a test that's performed and a report that is in turn generated by a third party. That third party for us was UL, which is Underwriters Laboratory. We provided them with multiple BOSS cabinets full of real batteries, and those batteries were basically drilled into and thermocouples were installed. The batteries were heated with a forced external heat, so they wrapped cells with heaters, trying to force a fire on the system and measuring the temperature all around. So when they forced external heat into the system and forced that battery to go into thermal runaway, simply a few cells that were in direct contact with the heated wrap itself did go into thermal runaway, of course, and then the surrounding cells, the thermal runaway did not propagate. So there was no risk of fire. The temperature on the back wall behind the BOSS cabinet only rose 5 degrees Celsius. This is not even really significant. And the point is here is our batteries could not be forced to catch fire or cause a fire, even in the worst catastrophe that you could have happen to a battery. They're not capable of simply lighting a fire and then burning your home down. It's just not going to happen. Now, lastly, before jumping into Q&A, I want to talk about our Elite Installer Qualification Program. So we offer a kind of a rewards program for returning installers. We want you to be happy with our product. We want you to be comfortable customizing it to different customers' applications. And therefore, if we know you are confident and doing a good job installing our products, we can add you to our installer map and show you off. And this is going to put your logo, location, and contact information on our installer map. Not only is this something that customers view, this is something our sales team uses to route the right leads to the right installer in their area. Beyond that, we're going to give you $25 cash back per battery install. This is a limited time thing, so make sure you sign up quickly to get your cash back before that program ends. We are giving away free swag upon joining, so we'll mail you a box with a bunch of goodies, and you'll have access to a senior level technical support phone line. So if this is something you're interested in, if you're already installing our batteries, make sure to sign up for this. It's a no-brainer. Now, Lastly, I want to jump into the Q&A before wrapping it up today. So if you've got any remaining questions, make sure to post them into the question bar. Can we have recordings of this presentation? Recording will be sent out automatically to all registrants. Give it about 24 hours. Does the SimpliPhi battery use FETs to control charging current? Therefore, you won't need closed loop communication with the inverter to manage charging current. No, it does not. So here's how it works. If you are paired with the inverter, the closed loop communication tells the inverter to do the work of reducing charging current. If you're not communicating with an inverter and you exceed the charge currents that we mentioned a few slides back, let's go check them out. If you're not paired with a communicating inverter and the charge rate of the SimpliPhi batteries exceeds these values, the SimpliPhi is simply going to open circuit. It's not going to be able to throttle the charge current. That's something that a charge controller and inverter are the only things that can do that. The batteries themselves, I have never seen a battery capable of throttling current. But if this current is exceeded, it will just open circuit for the entire battery to prevent damage in a worst case scenario. Now, if you're a customer, you really don't want the battery opening circuit because that means your power is out, right? That means your battery is not backing up your loads. So that's why I say that you really should only use the SimpliPhi in applications where it is communicating. So it will protect itself, but open circuit means not perfect operation of the system. Glad that was able to answer your question there. If we see temps below -20 Fahrenheit, will insulating an access cabinet allow the solar arc to keep batteries at temperature, or are heaters still recommended? I would say at -20 Fahrenheit, I definitely would recommend a heating pad if the access cabinet is, outside and not in a garage. The heating pads will use a decent amount of electricity, so make sure you insulate that type of cabinet there at -20 degrees Fahrenheit. That's a pretty significant temperature right there. Also to be considered on that type of system is how often and for how long are the batteries going to be exposed to that -20 degrees Fahrenheit? So is it just a couple mornings each year in the dead of the winter that before the sun comes up for a couple of hours it'll be -20? Then I would say no. I would say just disable charging below freezing and don't get heaters. If you've got a solar arc and SimpliPhi batteries, charging below freezing is already taken care of, and then you will not need heaters on that type of system if you're okay with just sacrificing those couple of hours each year. But if you're consistently seeing -20 degrees Fahrenheit, maybe you're somewhere like Michigan or Alaska, that is definitely a place where I would put heaters in any boss cabinet installed outside for sure. Awesome. Looks like that's all the questions we got today. Thanks for joining, and we will see you next time.